In session 28 here, we're going to extend our coordinate graphing by just a little bit. The only thing different that we're really going to be doing here that we did not do earlier on in our earlier sessions is that now we're going to include extending our graph into the portions of the quadrants that deal with negative coordinates. So that's really the only thing that's different here. Let's take a look at our bottom equation here. Y equals x plus 5. That's our function. What I've gone ahead and done is create a table here. Here's the x row, here's the y row, and I've gone ahead and started selecting some values for x and then subsequently for y. When x is 0, what's y? We'll stick the 0 into our equation. 0 plus 5 is 5, so when x is 0, y equals 5. So there's our 0, 5. Next is 1, 6. When x is 1, y is 6. Well, how do we come up with that? Well, I took the number 1, put it into my equation. Y equals 1 plus 5. 1 plus 5 is 6. Therefore, x is 1, y is 6. Then what I did is I went ahead and chose some negative numbers. What happens when x is minus 1? We'll stick a minus 1 in here for x. Y is equal to minus 1 plus 5. What is minus 1 plus 5? Well, it's 4. So when x is minus 1, y is 4. And for each of the following ones here, I did the same thing. For minus 2, I plugged it in. Minus 2 plus 5 is 3. When x is minus 2, y is 3. When x is minus 3, plug that in. Minus 3 plus 5 is 2. So when x is minus 3, y is 2. And so on, all the way up to minus 6. Once we get an x value of minus 6, we plug that in there. Y equals minus 6 plus 5. What is minus 6 plus 5? Well, it's minus 1. So when x is minus 6, y is minus 1. So let's go ahead and plot these points and see if we can see what's going on here. Our first point is 0, 5. So there's our, just as a reminder, x goes on the horizontal axis, y goes on the vertical axis. When x is 0, y is 5. Well, here's the x is 0, 1, 2, 3, 4, 5. There's our first point. 1, 6. Come over here, x is 1, and go up 6. That'll be right here. Next, though, we're going to start going the other direction and choosing some negatives for x. When x is minus 1, y is 4. So we go to the left of our origin, minus 1, then up to 4. Our next point is minus 2, 3. Minus 2, 3. Our next point is minus 3, 2. Minus 3, up 2. Our next one is minus 1, 4. Or excuse me, minus 4, 1. 1, 2, 3. There's minus 4, up 1. Our next one is minus 5. 1, 2, 3, 4. Minus 5, 0. And then our last one is minus 6, comma, minus 1. There's minus 6, and there is minus 1. So before I go ahead and connect these lines, can you remember which quadrant this point is in? Remember, we have 4 quadrants. This over here is quadrant 1. What about these points in here? That would be quadrant 2, and then this final point here would be in quadrant 3. Now I'm going to go ahead and connect these, and we can see that what we have here is a straight line. And that straight line there is the graph of our function y equals x plus 5. Now, does the literal graph stop there? Well, no, it doesn't, because this graph only includes the points I chose. But technically, this graph goes on forever. This line, because this line goes on forever. So whether or not we always write the arrows at the end here, it's understood that when you're graphing an equation of a line, that line does in fact go on forever in both directions. And that's what the arrow there indicates. Over here on this page, on this screen, we're going to take a look here at a function where we have x being squared. And this is, once again, is going to give us a different appearance. This is not going to be a straight line. So I went ahead and chose some values. When x is 0, 0 squared is 0, 0 plus 1 is 1, so when x is 0, y is 1. When x is 1, I put that in. 1 squared is 1. 1 plus 1 is 2, so when x is 1, y is 2. Here I went then and bumped it over to a negative number. When x is minus 1, well, what's minus 1 squared? Well, minus 1 squared is minus 1 times minus 1. What is minus 1 times minus 1? Well, it's a positive 1, because remember, a negative times a negative is a positive. Positive 1 plus positive 1 is now positive 2. So when x is minus 1, y is also 2. If we plug a positive 2 in here for x, 2 squared would be 2 times 2 plus the 1 equals 5. So when x is 2, y is 5. And then the last one I selected was x as minus 2. If we go ahead and put a minus 2 in here, what's minus 2 squared? Well, minus 2 squared is minus 2 times minus 2. What is minus 2 times minus 2? Well, it's a positive 4, because once again, a negative times a negative is a positive. And that positive 4 plus 1 would then be a positive 5. So when x is minus 2, y is a positive 5. Let's go ahead and plot those points, these 5 points. We have 0, 1. So there's our first point there. And just to illustrate this a little bit better, I'm going to go ahead and just stretch this out just a little bit. Well, I'm running out of room up here, so I'm just going to back off on that. Hopefully you can see the fact that this is not a straight line. Next, our value is x is 1, y is 2. So I come over 1 on my x and up 2 on my y. My third point is minus 1 and then a positive 2. So I come here to my origin, I come over minus 1 and then up to a positive 2. And then we have 2 more points, positive 2, positive 5. Come over on the x, positive 2, and then up, positive 5. And then same with our last point. Here we come to the left, minus 2, and up 5. And I put that one just a little, I put that one too high. That actually belongs there. So we'll go ahead and cross that out. So at this point, you might be tempted to say, oh, this is just a straight line that goes this way, and then another one that goes this way. But in fact, it's not, because if you remember from earlier, whenever we have a variable that has a square to it, in this particular case, x squared, we're going to have some type of a curve. And that's, in fact, what we got going on here. We actually have a curve that goes something like that. Okay, then, we can see here that by incorporating negative numbers, we are now able to use our coordinate graph in all 4 quadrants, and choosing negative values for x and then calculating out y is something that you oftentimes need to do in order to quickly and accurately make a graph of a function. Okay, then, that brings us to our review page. To graph a function, it's often helpful to choose some values for x, find out what the corresponding values are for y by solving the equation, and then by putting these results into a table. Once they're in a table, you can then start plotting these points on the coordinate graph, much as what we have done here in this particular lesson, session 28. Okay then, that'll wrap it up.